So we want to see where that last formula came from so we can understand it. It makes it a lot easier to remember. So remember, compounding is when you calculate the interest earned and then add it into the previous amount that was invested so that that amount, additional amount, will also earn interest. So at each compounding, one earns interest at a rate that's 1/n of the interest per unit time, usually per year. So if you say you had 10% interest per year and you're doing it monthly, n would be 12 times per year. So you're compounding 12 times per year. So how much interest would you earn at each compounding? Well, you'd earn 10 divided by 12 because it's 10%. 10% is 0.1. 0.1 divided by 12. Percent means per 100. So if I say 10%, I'm saying 10 over 100. So when you put it in for R, you don't put 10. You put 10 over 100, which is point, and usually in decimal form, right? So you put in 0.1. Okay? You're not, unfortunately, most textbooks say you're changing it to decimal form. You're not changing it to decimal form. You're just dividing, you're writing out what it says. If it's 10%, it means 0.1. 10 over 100. 10%. Cent is 100. It's Latin or French. It's both, actually, but it's like a penny. There's 100 cents in a dollar. Cent means 100. Okay? So if I had 0.2%, like some interest in savings accounts and checking accounts are still like 0.3%. You're not changing that to a decimal because it's already a decimal. 0.3% means 0.3 divided by 100, which means 0.003. So you would use R equals 0.003. Hope that's clear. I think your textbook actually says it wrong, but that's okay. You just, as long as you know what it means. Okay, so back to this. So I listed out the compounding so you can see where the formula comes from. So I'm going to start with the 0th compounding. So that means I haven't added any interest in yet. So it's just the initial amount that I put in the bank. That's called the principal. That's P. You can think of P as P naught, P sub 0, P at times 0. Just like population at times 0. Because I'm going to have a P1 and a P2 and a P3. It's P at the first compounding, P at the second compounding will be P2, P at the third compounding will be P3, etc. Okay? So the first compounding, I'm going to end up with this much. Now, where did I get that? So the new principal after the first compounding is P1. So that's P, the original principal, plus R over N times P. What's going on there? Again, it's easier to understand formulas if you think of specific numbers. So let's just stick with 10% rate annually. And we're compounding monthly. So N is 12. So what you're doing is you're saying, okay, 10%, that's 0.1, but I'm not going to get all of it. Each month I'm only going to get 1/12 of it. So it's 0.1 divided by 12. That's the R over N. So that's my interest rate for the month. So that's the monthly interest rate is R over N. Take the monthly interest rate times the principal, you get the monthly interest, which is Rn times P. You take the monthly interest and add it to the original amount, and you get the new total amount. And that's why I have P plus R over N times P. Now, factor out the P on the right side of the equation. And you get P times the quantity 1 plus R over N. That's where the P times 1 plus R over N in the formula we just saw on the previous page, that's where it comes from. So the 1, notice the 1 here if you distribute this out, that's the 1 actually comes from the P, the original principal, right? So the 1 gives you your original money back. The R over N gets multiplied by P, gives you the interest. So this is the interest earned after 1 month, R over N times P, okay? So the R over N gives you the interest that you add in. It's the compounding. The 1 gives you your money back because you need to at least get your original money back, right? Okay, at least if it's a positive rate of return. Okay, so that's after 1 compounding. What happens after 2 compoundings? Well, after 2 compoundings, you take, this is from the previous line, so this is the principal 1, P1, and you're going to add the interest rate times P1. That's what this says. Now I'm just going to factor out the P times 1 plus Rn, and you'll see what's actually happening is you take the original principal, I've compounded twice, this is 1 compounding, multiplying by 1 plus R over N. So not too surprisingly, 2 compoundings is you multiply by this twice, see, which we would normally write this way, right? So this number up here is how many times you're compounding the interest. It's that simple. This is the rate per time that it's being compounded. So if it's being compounded every month, this is the rate, the interest rate per month. If it's every week that you're compounding, this is the interest rate per week, which is the annual interest rate divided by 52. See? This is to get your original money back, and that's your original money. Okay? Now, what would you guess would happen if on the third one? Well, you multiply by 1 plus R over N again. That's your multiplying factor. Every time you do a compounding, you multiply by that factor, 1 plus R over N again. So again, 3 tells you what compounding you're on. See? So now if I go up to N, I got the wrong letter. Let's back that up a little bit. So if we go up to N, P sub N, that is the nth compounding, will be P times the quantity 1 plus R over N raised to the nth power. So what is this? So suppose it was annual interest and you're compounding monthly. This would be how much money you would have after 12 months, because N is 12. So that would be the amount of money you'd have after 1 year. Oops, what happened? I went back to M again. Okay, now we got it. So that's the first year, right? But we're going to leave it in there longer. We're going to leave it in there till N times T. N times T. Yeah, that's right. So if you keep going up until N times T, and just assume for a moment that T is an integer, positive integer, then you're going to replace that N in the previous equation there with NT. So say you're doing 3 years, then that exponent will be 36. It's the number of times you've compounded, right? So if N is 12 times per year, you're compounding 12 times per year, and you for 3 years, that's 36 compoundings. That's the N times T. So the N times T is telling you how many total compoundings you had. Now, T doesn't have to be an integer. It could be any real number, right? But the integers are going to tell you like the number of years, because T is in years, right? But when we compute these things, it doesn't have to be by years. It could be, T could be like 1.3 or something, 1 3/10 of a year, right? Anyway, that's how that works.